How do you define heat equation?
Between heat loss or gain by a body to its mass specific its capacity and intensity.
Temperature is called heat
Equation.
equation. Heat equation, right? Students, now let's check one thing here. How many graphs are given? Two graphs. This is um, volume and temperature graph. This is density and temperature graph. These are two different graphs. Graphs, right? What does it show? It shows that water has minimum volume at 4 degrees centigrade. Water has minimum volume at, it means molecules are compact at 4 degrees centigrade in comparison to others. So volume less, density high. So what is the relation between volume and density? Do you know? How do you define density? Yeah, mass per unit volume. Rho equals to m by v. If so, m equals to rho v or dv, no problem. Then what can you write here? Mass is directly no, we are not going to show relation between mass and this one. We will show the relation between density and volume. Density and volume. Okay, check here. Density is directly proportional to mass, but density is inversely proportional to volume. More volume, less density, less volume, more density. This graph also shows the same thing. Here is less density at how much degrees? Sorry, less volume at how much degree centigrade? 4 degree centigrade. So density is maximum at 4 degree centigrade. So water at 4 degree centigrade is much heavier than water at other temperatures. Because of that, if this is water body, during winter season, upper part changes into ice. Let's say it may be minus 10 degrees centigrade. At minus 10 also there is ice. At minus 20 also ice. Minus 1 degree also 0 degree ice, but slowly it may change into water also, right? Then what is this? 1 degree, 2 degree, 3 degree, 4 degree. At the base there is water of how much degree? 4 degrees centigrade. Always you just keep in mind. So you might have noticed, when a bottle filled with honey, filled with what? So here is one bottle filled with honey. Here is another bottle. How is it filled with? It is filled with ghee. Where? Ghee. And it is filled with water. How many bottles are there? 3 bottles. One filled with honey, another filled with ghee, another filled with water. Where are they kept? You keep that ball pen down. Ritika, don't take that ball pen. She's afraid. Ritika may take and go home. She will not go. She will stay there only. Why are you worried? Catching loony way. Okay. When these 3 bottles are kept in deep fridge, because in normal temperature or normal fridge, it may not solidify immediately. But if it is kept in deep fridge, then what can we notice? Lower portion of honey becomes or changes into solid, then upper portion. So at first this becomes solid, then upper one. And in case of ghee also, lower portion. You might have seen that ghee bottle, right? Lower portion solid, upper portion there may be liquid. It means all the liquids, they solidify from lower part, lower portion. But water is that thing which solidifies from upper. Upper portion there is solid and below portion there is liquid. Because it is at how much degree centigrade? 4 degree centigrade. But if you keep that in the temperature below, let's say minus 10 degree centigrade, then all will change into ice. But it starts being or changing into ice from upper level. This is the thing. Sometimes question can be asked. Honey solidifies from below part or lower part, but water solidifies from upper part. Why? Main thing is the density of honey is more at solid state, but density of water is more at how much degree? 4 degree centigrade in this one, right? Remember, eh? So it was already discussed. We discussed those expansion also, and today we are going to discuss one new thing. What is that? Specific heat capacity. What do we discuss? Specific heat capacity. Before starting that, let's remember the heat equation. What is the formula of heat equation? Q equals to M times S times dt. What is given here? Q equals to M times S times dt. What is M? Mass. What is S? What is this? Yeah. Now this one we have to discuss. What is this? Specific heat capacity. Specific heat capacity. Okay. Here is given one activity. In this activity, what is given? Here are two test tubes. What are here? Two test tubes. In one test tube, what is kept? Kerosene. Another test tube, what is kept? Water. Right? And where are they kept? They are kept in the beaker containing water. And thus it is heated. When this beaker is heated, then what will happen? This lower pressure becomes hot, slowly heat passes upper one, and this also gains heat, this also gains heat, right? Kerosene also gains heat, water also gains heat by the heat present in this water, right? And this level of mercury, will it increase or not? So level of mercury of water increases fast or kerosene increases fast? Or they will increase together. Or in our kitchen also we can do such type of experiment. In two vessels, you can take two different liquids. In one vessel you can take milk, another you can take water, and you start heating. Which boils faster? Milk boils faster. Why? What's the reason that milk boils faster and water boils slower? It's because of heat capacity. Means some liquids they can absorb more heat and their temperature rises slowly. Some liquids they can absorb less heat even though their temperature rises fast. Here is one chart. See here. Here are some solid, liquid also and gases also. Some they are in solid state, some they are in liquid state, some they are in gaseous state. Here is one chart. It hasn't come? Oh, it has come. Good. Now control this and do it. Different substances are here. Here is given lead, but lead also can be melted and changed into liquid. Because we have studied that a body can have three states, right? Solid, liquid and gas. Lead, this is a kind of metal. What is it? A kind of metal. So especially what do they do? They add this lead in petrol. So that it's I think quality, there's no quality, consumption will be less they say, but it's a very dangerous one. When lead bonds with oxygen, lead oxide is formed, that is very much harmful and people suffer from cancer. Okay, different substances are given here. What is the first one? Lead, gold, mercury, silver, brass, copper, steel, iron, glass, sand, aluminium, air, petrol, water, olive oil, kerosene, ice, paraffin, alcohol, water. Right? Okay, what is given here? Some values are given or not? What is given? 126. Here? Here? Okay. In thermometer, what do they use? Mercury. Do they use water? Why don't they use water in thermometer?
There's more capacity of
Specific heat capacity of mercury is very, very less. How much is it?
150.
But specific heat capacity of water is.
100.
But what is specific heat capacity? How do you define? What the definition? Is the definition given somewhere else? What the definition? Just check it here. The amount of heat required to raise the temperature of unit mass. Unit mass means 1 kg substance by how much degree centigrade?
1 degree centigrade or 1 kilo.
1 degree centigrade or 1 Kelvin. Now look at here. Here is water. What is here? And what is here? Mercury. We have taken 1 kg water and 1 kg mercury. Water is at how much degree centigrade? Mercury is at how much degree centigrade?
1 degree.
Both are in same mass, same temperature. Now, means it must be 1 kg. Eh? From 10 degree we want to make how much degree centigrade? From 10 how much we want to make? So, how much heat is required to raise the temperature of 1 kg mass by 1 degree centigrade? We need how much joule? Sorry, 4200 joule is required. But for mercury, 140 only. So, to change the temperature of mercury, we need heat, more heat or water?
Water.
That's why mercury can be used in thermometer because temperature rises very fastly, isn't it? But to increase the temperature of water, we have to supply more amount of heat. So, actually this specific heat capacity is the heat absorbing capacity also. Can it absorb more heat or less heat? Can it absorb more heat or less heat? So, are you feeling sleepy? Sit correctly. Want to slaps? I'll give it to you. After getting slaps, barbaric will be. Barbaric. Less specific capacity can gain heat fast or gain temperature fast, means gain heat and temperature rises fast, and loses heat fast, temperature also decreases fast. But if specific heat capacity is more, it gains heat slowly, temperature rises slowly, and temperature falls slowly. In hot bags, what do you use? Water is used, no? So that hot bags water remains hot for longer time. But in our village, there is no hot bag, no such stuffs. And what we used to do, we used to heat that stone. We used to keep that stone in that onge, no? And I'm sorry, no, torijol that is for massaging only. But that to keep the stomach warm, we used to keep that stone in those burning fire, and afterwards we used to wrap with the help of cloth and keep. After 1.5 hours or something, sometimes later on, cool, quite faster one, isn't it? Because gains heat faster, loses heat faster. But here, water gains heat faster, sorry, slower, loses also heat slower. So, what is the advantage of having more specific capacity? Actually, water has more specific capacity. What are the advantages? Number one, water can be used to cool down the engines of vehicles. What do I say? Cool down the engines of vehicles. Vehicles, when they are in action, more heat is produced or less heat is produced? More heat. And if something becomes hot, problematic or not? If engine becomes more hot, then it may damage as well. That's why to cool it, what is kept in that engine? Water. Nowadays they use coolant also. What do they do? Either water or coolant. What do? They absorb more amount of heat and the engine remains cool for longer period of time. Okay, cool for longer period of time. And next thing, that is the advantage of having more or high specific capacity. It is used to cool the engines of vehicles. Not only that, because of more specific capacity, water can be used in hot bags. Why is it used in hot bags? To get heat for a longer period of time. You know, when 1 kg water cools down, suppose here is water. What is here? Water at 40 degrees centigrade. How much water is here? 1 kg water at how much degrees centigrade? 4 degrees centigrade. Now, if this water's temperature becomes how much degrees centigrade? How much heat do we get? We get 4200 joule heat. When from 1 kg, if 5 kg, then we will count accordingly. Like if the temperature changes from 40 degree to 30 degrees centigrade, then how much degree change? Then at that time, yes, 42,000. So we get more amount of heat. That's why water is used in hot bags. It can absorb more amount of heat. That's why it is used in engines of vehicles. Okay, that is the important. Next one is here. The night in a desert is very cold, while the day is very hot. Why? Why day is very hot? I think so, right? How is the desert filled with? Sand. What is the specific heat capacity of sand? It's not given. Actually, 800 joule per kg per degree centigrade. Good. What is the SI unit of specific capacity? What is it? Specific heat capacity is expressed in unit joule per kg per degree centigrade, or J kg minus 1 degree centigrade minus 1. J kg minus 1 degree centigrade minus 1. Right? These things you have to remember. One question. The specific heat capacity of water is 4200 joule per kg per degree centigrade. What is given here? Specific heat capacity of water is 4200 joule per kg per degree centigrade. What does it mean? What does it mean? Tell me. It means that how much joule is given here? 4200 joules of heat energy is required to raise the temperature of 1 kg water by or through how much degree centigrade? 1 degree centigrade. Very simple is it. The specific heat capacity of water is 4200 joule per kg per degree centigrade. What does it mean? It means that 4200 joules of heat energy is required to raise the temperature of 1 kg water by or through 1 degree centigrade. If I say the specific heat capacity of a substance is how much? 200 joule per kg degree centigrade. What does it mean?
200 joule is required to increase.
It means that 200 joules of heat energy is required to raise the temperature of 1 kg mass of that substance, not water, 1 kg mass of that substance through 1 degree centigrade. Is it okay? So, desert, daytime, night time. Why? Daytime, the sand becomes hot faster. It because of less heat also, temperature rises faster and becomes very hot. During night time, it loses more heat and temperature goes much more below, very cold, right? Now next important thing we are going to discuss today is sea breeze and land breeze. Okay, what do you mean by sea breeze and land breeze? Do you know?
This we have already studied in some.
Okay, Samajik also.
Yes.
Okay, tell me, what is sea breeze? What is land breeze?
The water rise temperature slowly and decrease slowly. Yes. But
Actually,
in
listen.
land, yes.
Breeze means soft blowing air. When the air blows softly, that is called breeze. Land moves air moves from one place to another, either from water bodies to land or land to water bodies. So, this is night time. What is this? Night time. At night time, cool land breeze moves from land to sea. That is called land breeze. Movement of cold air from land to sea is called land breeze.
She is at the
No, tell me. Figure of sea breeze. Where is sea breeze?
Here goes. So this is opposite here. At day at night. Night is this side.
That's why I just say just
Sorry,
breeze.
sorry.
No, I just listen. No. Warm air, does it come or cold air comes? While blowing, cold air comes to us or warm air comes to us? Cold air comes. No. That's why during daytime, look at here. This figure is a bit wrong, answer. This one just because of this figure they are confused. During daytime, land is warmer, water body is colder. Why? The specific heat capacity of land is very less. The specific heat capacity of water is more, so it can absorb more heat and temperature does not increase. No, but its temperature increases fast. So hot air rises up and cold air moves from sea to land. Cold air moves from sea to land during day. What is it called? Sea. That what is it called?
Land.
Sea breeze. What is it called? Sea breeze. And during night time, cold air blows from land to sea. What is it called? Land breeze. Sea to land, sea breeze. Land to sea, in that way. In which side it is going? Cold air blows from one part to another part. Well, sometimes when you go outside now, I think there is no more movement of air. Temperature is equal. Sometimes all of a sudden the part becomes hot, air rises up, and cold air comes. No, that is also breeze. Sometimes breeze, hurricane, some other things as well, right? So here, during daytime, cold air blows from sea to land. What is it called? Sea breeze. During night time, cold air moves from land to sea. That is called land breeze. Okay? Land breeze and sea breeze is caused due to variation in temperature. Variation in specific heat capacity of land and sea. What is the specific heat capacity of land? How much? And this one? So which one becomes hot faster?
Land.
So during day, land becomes hot faster. Cold air blows. What is it called? Sea breeze. During night time, land becomes cool faster. Cold air blows from here to there. What is it called? Land breeze. Okay. This is the thing. I think let's do this much today only. Right? Remaining will be discussed later on. Now take out the book and read. Afterwards, a note making.